G'day all and welcome back to the Cartographic Projection channel. It's been a while. My name's John, a cartographer from Australia, and what we're doing in this video is measuring the sunrise and sunset angles. This was part of a set of measurements I did comparing globe earth to flat over a 2-day road trip in January of 2026. And where we're going to be doing it is a place called Yamba in South Australia, just on the South Australian-Victorian border. And if that zoom in was a bit quick for you, here's just a bit of a pair of maps on where it is. Okay, here we are at Yamba. Beautiful place, except for all these bloody flies. Now we're lined up. That is magnetic south. That is magnetic south. And I've got everything colour coded so that we can come back in the morning. After doing a sunset tonight, we can come back and do sunrise in the exact same spot tomorrow morning. Now this thing, this tripod, there is not a single ounce of metal in it. It is all foam cordboard or core flute and leftover cardboard tubing from work. A lot of super glue, a lot of PVA, and a lot of Gorilla Tape. So rather than trying to turn a stiff compass, I can just line up this arrow with the sunset when we get the last skerrick of sun on the horizon as best as we can, and then I can line the compass up. So we'll see how we go. Now I will say that the reason there's no metal in this tripod, and there's no metal around here at all, I'll get rid of those in a sec, is because of someone else who did sunset readings that we all know well. The protractor idea, I sort of had it, but that was from Andrew Johnson, Edward, whatever, I don't know how to say his name, and he sort of came up with that idea, and should be able to tell within, I reckon, about 1/5 of a degree. The expected angle, if I can get that lens flare to stop a bit, is 244 east-southeast. So still south of east, even though we're in creeping into mid-January. And then we'll see what we get for the morning, and we should be able to work out the magnetic declination as well. Well, I've spotted at least one fly already. Is this worth it? Hopefully. Bloody hell. And it's not shrinking, by the way. Can't tell from this iPhone camera, but that is just sinking below the horizon. Here we go. Starting to set now. Let's line her up. Looking pretty good. Very easy to then rotate the tight compass to match this. And done at 8:15. Time and date said 8:20, but we're not exactly on prime waterfront property here, so let's measure that up and see what we got. That puts me right around the 244 that it said on timeanddate.com, matching globe earth predictions. Okay, so we're back here in the morning, just about waiting for the sun to come up. Correction on where I was a little bit out last night. I'm on 236 rather than 244. That might be, I'm not sure if that's the quality of the compass. I'll check that with the phone after all this. But the same error should be on this end as well. And the sun is about to peak over the horizon. It is 6:10 and the prediction is sunrise at 6:12 at 116 east-southeast. So I think we're going to be going pretty well, I think. And these bloody flies, this is where we are at a rest stop near Yamba in South Australia. Victorian-South Australia border is just over there. And there's a quarantine station for people to drop their fruit and veggie just up the road there. So here is a place where everyone can dump all their fruit and vegetables to stop any fruit fly infestations. And of course that's why there's so many bloody flies here. Didn't really think that one through. I should point out that there are quite a number of bins there. This isn't people just dumping their stuff on the side of the road there, but birds getting into the bins and spreading it all over the place, and that's why there's so many flies. And also, while we're here, Yamba is a location of the big Dunlop tyre. Apparently we love our big things in Australia, and this one was built when Adelaide got the Grand Prix in 1985 to welcome people driving across the border. And there we are, the first peak of light over the horizon. Try and line the camera up. And I think we're dead on. That was at 6:14, so I'd say that's the difference between us and sea level. Now, time and date predicted 116. I've got a fraction over 107, which means I seem to be about 9 degrees out on both readings. So I'm betting my original magnetic south is out of fractions. So this is an example of how absolutely brain dead you can get after driving nearly 900 kilometres in a day and then trying to take some measurements when it's hot and you're covered in flies, and then getting up in the morning and trying to do it all again before sunrise. I am literally talking about measuring the magnetic declination, and then I'm standing there confused about why my readings seem to be 9 degrees out on both sides. Just have a think about it. So let's have a look at the measurements. Got a large ground protractor showing east and west lining up with magnetic south. There's our two readings, and we've got those figures when I've zoomed up on them. I reckon 107 degrees for the sunrise and 231 degrees for the sunset. Both of those being towards the south, south of east and south of west. So to sketch that up, just putting south at the top just to piss people off, I've got those angles, and the difference between them is 128.8 degrees. Split that in half, we get 64.4 on each side. Add those to whichever angles, 171.5 and 171.7, giving me an average of 171.6. To get our declination, I subtract that from 180 and I get 8.4 degrees, or 8 degrees 24. Comparing that to the globe earth prediction of 8 degrees 56 for the exact spot I was there, it gives me an error of 0 degrees 26 minutes, less than half a degree. And now we can use that declination to compare our measured angles to the globe earth predictions. Adding them together, I get 115.7 degrees and 244.5 degrees. The predicted globe earth angles were 116 and 244. East southeast, west southwest. You'll notice they're still both south of the east-west line. So that gives me errors of half a degree and less than 1/3 of a degree, which I'm pretty pleased with. So to recap, I measured a declination of 8 degrees 24 compared to the globe earth prediction of 8 degrees 56, an error of a fraction over only half a degree. I measured the sunrise and sunset angles and compared them to the globe earth prediction, and I got an error of half a degree and less than 1/3 of a degree, which I am extremely pleased with. So if we're talking flat earth predictions, well, you tell me what they are. If you believe that the Earth is centered on the North Pole and the Sun rotates around in circles, then this is your model or something like it. If it's not, then you produce one that shows what you believe. So we've got the Tropic of Capricorn here. The Sun cannot go any further south. So if you can't think in 3D, then you tell me how I made these angle measurements, because yours should be something like this. What are they? What were the times? No one on the flat earth model can tell me. An interesting aside, for those who insist on using just their phones, I waved this around in all different directions for a good 30 seconds or so, trying to get it to calibrate before I laid it down. And as you can see, it's still out by what I worked out to be 11 degrees. In hindsight, I thought maybe I had it still set on true north, but apparently not. So for people who still insist on using only their phone as a compass, you may need to calibrate it far more than you think before you actually try and take a reading. Just note that for the future. So given a chance, what would I do next time? Well, I'd probably show a lot more of the setup of the tripod and laying out the string lines, lining up with the toothpicks on the arrow, using the binoculars. Well, as you can see, there was a monocular because one of the lenses fell out and I could not thread it back in with all the flies in my face. I'd show a lot more about how I lined up not just magnetic south but all the other ones as well. And also the coloured stakes that I did so that I could get everything in the exact same spot for the next morning, which I thought was interesting. I'd also show a lot more detail in laying the compass out on the arrow. I was a bit disappointed when I went back over everything that I hadn't shown more of that, and I'd make sure I would actually have that in a lot more detail next time. I would probably change the protractor to show the angles more. I did design it as a protractor, but what I would probably change it to is the 90, 180, 270, which would make it a lot less confusing when you're tired at the end of a long day and just waking up from the morning. And finally, and probably most importantly, there is something that I didn't bring that I would definitely bring a massive supply of next time. Yes, insect repellent. Every Australian has a massive supply of this, and I didn't bring any, and it would make life a lot easier next time if I could get all those bloody flies out of my face while I was doing stuff. Well, if you've made it this far, I'd like to say thanks very much for watching. Once again, I'd like to thank Andrew for his help and his suggestions on things for this. I'd call this a pretty successful set of readings, pretty accurate results, pretty small errors. Got to be happy with that. I'd also like to thank my family for putting up with me in organising this trip and all the bits behind the scenes. While you're here, feel free to like and subscribe, and with a bit of luck I'll be having more videos coming out within the next few weeks on everything I did on the trip. So until then, take care all. Hope to see you soon. Bye.